Hi everyone. We are going to present the paper evaluating robustness and reliability of C-NIDS for IoT networks in virtualized environments, submission ID 9287. Nowadays, several networks operate standalone to meet their environment requirements. However, since these networks need protection to work securely, a network intrusion detection system runs on the gateway to analyze the data traffic traversing needs. The integration of these networks requires robust and collaborative security solutions, thus evidencing the use of collaborative network intrusion detection systems. However, most current solutions neglect a reliable evaluation of such systems. Our main contributions are to evaluate C-NIDS performance by distinct configurations and attack scenarios, provide a detailed and reliable C-NIDS evaluation, and promote the development of more resilient and adaptable security solutions for integrated IoT environments. Our evaluated scenario comprises IoT networks mimic smart home environments. Each one encompasses 15 IoT devices which collect data and send it to a data monitoring server to keep a local view. The servers communicate with each other through the gateway and exchange local information to hold a general view. A NIDS runs on the gateway to analyze data traffic traversing it in order to identify and mitigate network intrusions. We emulated DDoS attacks from a botnet targeting the data monitoring server. We set up two attacks aiming to compromise the service provided by the monitoring service. Such a strategy allows us to verify NIDS behavior during attacks, since they must share attack-related information to improve overall security. The attacks employed UDP and ICMP protocols. We built a test bed to implement the network environment by applying several tools like Kubernetes and Docker. We set up each IoT device in a pod and put these pods inside a worker. The DMS server runs inside one pod and another worker. The NIDS operates inside one pod and in a separated worker. To emulate DDoS attacks, we built a botnet in another worker by these three instances of the Bonese tool. We started a C-NIDS evaluation by verifying the throughput in each network when NIDS operated without pre-configured rules. Therefore, DDoS attacks freely reached the DMS of each network, causing as much damage as possible to its functioning. In this way, the lack of NIDS protection in network operation, especially DMS, became evident, as we can see from the throughput of network 1. The other networks suffered a similar impact from the DDoS attack. Next, we evaluated the throughput in each network when NIDS operates with pre-configured rules. This time, NIDS blocked DDoS attacks, thus avoiding them to reach the DMS of each network, restraining the damages to their functioning. In this way, NIDS protection in network operations, especially DMS, became evident, as you can see from the throughput of network 1. The other networks presented a similar behavior against the DDoS attack. When evaluating the C-NIDS robustness and reliability, we computed low packet losses. Although some networks suffered high losses, generally they operate with low losses, evidencing NIDS effectiveness in detecting and mitigating DDoS attacks. In various conditions, networks experienced no packet losses. C-NIDS accuracy achieved 99.96%. As recalls, with a precision of 100%. These results highlight the benefits of C-NIDS collaboration. In conclusion, we presented a comprehensive evaluation of the robustness and reliability of C-NIDS in a virtualized IoT environment. Such systems allows the integration of autonomous networks by sharing information about detected and mitigated threats to improve overall security. In this sense, direct communication among NIDS is essential to reduce the damage caused by attacks targeting an IoT network. Therefore, the evaluation of C-NIDS in a virtualized environment evidenced the relevance of testing security solutions in scenarios mimicking real operation conditions. Thanks.